All right, let's dive right into this explainer. Today, we're figuring out how to take those fragile, personal coding projects of ours and actually transform them into lasting institutional assets. Because look, if you've ever built a custom script, an automation, or wrangled an API to fix an annoying bottleneck in your workflow, you know that rush of finally getting it to work. But what happens to that brilliant little creation when you're no longer around to run it? That's exactly what we're tackling today, architecting continuity.
Just imagine your school district's tech environment for a second. Honestly, it's often like this vast, unseen ether just filled with random scripts, scheduled automations, and API tools that literally nobody knows how to use anymore. They're all just kind of floating out there in the digital void. We've all been there, right? A critical process suddenly breaks, someone finally looks under the hood, and boom, they find this incredibly complex string of code written by a guy who left the district like 3 years ago.
And that brings us to the core problem, what we lovingly refer to as the tech graveyard. It's where good tools go to die. Usually the story goes like this. The builder left the district, or maybe they got promoted to a new role. Or honestly, sometimes the builder is still sitting right there, but it's been 6 months and they've completely forgotten how their own tool works. At the end of the day, undocumented tools become unmaintainable, and unmaintainable tools just get abandoned. It's a massive waste of time and institutional knowledge.
So, to make sure you get your builder's permits and keep your projects out of that graveyard, we're going to walk through 4 key steps today. First, avoiding the tech graveyard overall. Second, creating the comprehensive README. Third, clarifying with inline comments. And finally, documenting AI and review. Let's get into it.
Okay, Section 1. Avoiding the tech graveyard and making sure your tools actually survive you.
The main thing to grasp here is that securing your metaphorical builder's permit elevates your random script from a temporary personal project into a permanent institutional asset. Think about it. A personal project is incredibly fragile. It's totally unrecorded, and it practically collapses the second you log out for the last time. But an institutional asset that is documented, it's robust. It is explicitly designed to survive staff transitions. When you document your work, you're not just doing busy work. You are literally cementing your contribution into the foundation of your organization.
Moving on to Section 2, the comprehensive README, which is essentially the front door to your tool.
Building that front door takes a bit of a mindset shift. Your README file? Yeah, it's not actually for you. It's a letter of empathy to the poor soul who ends up inheriting your work. You've got to assume this successor has never seen the tool, has no clue why it was built in the first place, and is probably low-key panicking trying to figure it out. Your README needs to be the welcome mat and the instruction manual all rolled into one.
So a solid README clearly maps out a few essential things, so anyone can instantly get the gist. First off, what exact problem does this solve, and who does it serve? Next, what are the dependencies? Like, does it rely on a specific Google Sheet or maybe a third-party API? You've also got to spell out access instructions and required permissions. And please, be totally honest about any known limitations or bugs. Do not leave hidden landmines for the next person. Finally, throw in a support contact for troubleshooting. Hit these points and your successor actually stands a fighting chance.
All right, part 3, clarifying with inline comments. Think of this as your translation layer.
Now, this is an absolutely vital distinction for anyone writing scripts. The code itself tells you what is happening mechanically, right? It's the loops, the syntax, the variables, but your inline comments, they tell you why it's happening intentionally. Why did you use that weird workaround? Why on earth does the code pause for 3 seconds right there? The code is the machine, but your comments are the human logic driving that machine.
I absolutely love this rule of thumb. If you cannot explain it in a comment, you do not understand it yet. And man, this is especially dangerous right now for builders using AI. AI-generated code is incredibly compact and functional, which is awesome. But if you're just copying and pasting an AI script without actually taking a minute to comment the why behind it, you don't own that logic. You just imported a block box. Commenting forces you to slow down, comprehend, and actually take ownership of what the AI spat out.
And all of this really highlights why you need a handoff guide. This sits right between your README and your code comments. It's all about getting that crucial operational knowledge out of your head and onto paper. If a module updates and the tool breaks, how exactly do they fix the master sheet? If a new person joins the team, how do you modify admin permissions? And that last one is huge. If an API key gets compromised, what are the exact step-by-step instructions for rotating it? That's the survival guide that keeps everything running during a crisis.
Which brings us to our final section, documenting AI and review, future-proofing your work with the human finish.
For every single AI-powered component you use, you've got to document where it fits into these 4 workflow stages. Did you just use the AI to brainstorm some logic? Did you use it to procure a specific function? Was it doing the heavy lifting during the build phase? And, most importantly, how did you apply that human finish? By mapping it all out like this, the AI's role becomes totally transparent to the whole organization.
Drilling down even further, you actually have to keep a record of your prompts. It is definitely not enough to just say, yeah, I asked the AI to write a sorting script. No way. You need to record the exact prompt utilized. And then, just like with your inline comments, you need to explain why you designed the prompt that way. What constraints did you give it? Finally, make sure you note the specific AI model you used, because a prompt that works like magic in one model might completely bomb in another. Doing this ensures your district isn't stuck holding an undocumented AI black box.
Because here's the bottom line. AI should absolutely never fly solo. We always need the human finish. This is about fully institutionalizing the human-in-the-loop concept. AI is an incredibly powerful engine, for sure, but it desperately needs a human steering the wheel. When we document how a human interacts with, verifies, and finalizes that AI output, we're guaranteeing that the tool is safe, auditable, and built responsibly.
And that leads right into the mechanics of that review. Writing down your human review criteria is really the ultimate hallmark of responsible building. So who is actually checking the AI's homework? Don't leave it vague. Assign a specific role. What exact criteria are they using to judge accuracy or safety? And critically, what's the protocol if the AI's output totally fails the review? Setting up these guardrails means the tool stays reliable long after the original builder has moved on.
So here's a big question to leave you with today. Take a really hard look at the scripts, the automations, the AI tools you've poured your time into this year. If you won the lottery and just walked away tomorrow, would your tools survive? Or would they just end up quietly breaking down in the district's tech graveyard? Ask yourself if your work is actually ready for its builder's permit. Because building a great tool is only half the battle. Making sure it outlasts you, that's what makes you a true architect.